Thank you everybody for joining us today for the outdoor Wi-Fi design webinar here. I'm really excited to introduce you guys to John Murphy. He's a great engineer and has some really good information to share with us. I'm going to let him work through his slides and kind of share what he has. And at the end, we'll do a Q&A. You can throw any questions you have in the chat or in the Q&A part, and then we'll save those up to the end of the webinar and ask John for any advice that he has. I know this is a really needed conversation. A lot of people don't realize all the different options that you have for outdoor Wi-Fi access points, and I think there's going to be a tremendous amount of value. So thank you guys for joining us. We did put together kind of a neat web page that I'll share here in the chat as well. So, and if any of you guys have to step out early, we will be recording this webinar, and everyone that's registered will get a copy of the webinar recording. So thanks again for having us. And John, with that, I'll let you take it away.
Okay, thank you very much. Looks like I can't start my video, but that's okay. I've got slides, so I'm going to go ahead and share my screen, and we'll get going. So the topic of today, and hopefully my screen is sharing.
It was John, and then we just lost it for a second.
Sorry about that, technical difficulties. We're back. Okay, so the first thing I want to talk about is some of the challenges of outdoor Wi-Fi. First of those is oftentimes when we're talking about outdoor coverage, we have very large coverage areas. So one example of that is something like a campground. This is a common use case that we see for outdoor Wi-Fi. A lot of campground owners are seeing that, more and more customers are demanding Wi-Fi access when they go camping. So this is an example of one that you can see is quite large. So if you think about not only having to place access points to be able to provide coverage for all these RVs, but also the logistical problems in getting backhaul or signal fed to those APs. So whether that's copper, Ethernet, or fiber, or some type of like a radio bridge connection to get to those APs. So there are challenges both in just the area that you may have to cover, but also how do you get that AP connected to the network or to the internet. And then there can also be some power challenges in some of these outdoor areas. So we'll talk about that too. It's not just campgrounds. So, we do a lot of work with cities in these smart city kind of deployments where we can provide street level coverage for wireless users, as well as some wireless like IoT type devices and other IoT type devices, which we talk about at the end. So, whether you're talking about more of a rural environment or an urban environment, many times when you go from indoors to outdoors, the coverage demands require a lot more area to be covered. So that's the first challenge that we see. And then the other challenge we see is the obstacles that the signal has to either pass through or deal with in some way. Of course, this is a problem indoors as well. And many people will be familiar with the idea of doing like a predictive design for indoor coverage or even an active survey where we can take into account things like what is the attenuation through the walls in order to factor in how much signal loss there's going to be and estimate what the coverage will be indoors. When we move to the outdoors, it gets a little bit more challenging. Foliage in the form of trees and shrubs is really one of the bigger challenges. So unfortunately, the frequency bands that Wi-Fi operates at are very susceptible to attenuation from water molecules. So water will attenuate that signal quite strongly, and the leaves on trees are mostly water. So what this means is that where you have a densely foliated area like you see in this picture, it can be really challenging to get a signal through the trees. And of course you can, there are some differences between the frequency bands. So if we're talking about like 2.4 gigahertz versus 5 gigahertz, the 2.4 is going to go a little bit further, but it's still going to have some of those same challenges. And not only the fact that there are trees, but also, what kind of trees and how are they situated? So including the elevation at which the foliage starts. So here's another campground example where you can see in this case, there are no really leaves below a certain point. So there's a certain distance up the trunk where you start to get the foliage. And in some cases, what you can do is mount your APs a little bit lower and or trim back some of that foliage to be able to get a clear path underneath the canopy. And that can be very effective. Now, there are other challenges with that as well, which we'll touch on a little bit later, in that getting signal into some of those RVs can be a little bit difficult due to the height of the RV. So we need to deal with the fact that the signal doesn't propagate very well through foliage. And then also, the particulars of the individual sites that you want to cover. How are the trees laid out? What does that look like? Then, of course, we also have buildings and structures. So in a more urban environment, you may still have trees, probably less of them, but what you are going to have is a lot of these buildings. And in many cases, when you're dealing with things like concrete and brick, there's pretty significant attenuation that happens of the signal. But also in these urban environments, you can get a really high number of reflections. So as the signal travels between the AP and the client, or vice versa, that signal can potentially bounce off many surfaces. Anytime you have a flat metal or glass surface, or even some of these brick buildings, in some cases, you'll get part of the signal reflecting. And then all of these reflections can compound and make it hard for the device to interpret the signal. We talked a little bit about campers and RVs. So we do see, campgrounds are a pretty big use case. We see most of these RVs, some of them are fiberglass. Many of them have aluminum as part of the structure. And in many cases, you will not be able to get a signal through one of these RVs. So oftentimes the coverage will be through the glass, and tinted glass in some cases may also attenuate the signal. Now there is some good news here with RVs, in that many RV owners have a signal repeater, where you have a Wi-Fi device on the outside of the RV that can repeat the signal to the inside. And we're seeing more and more RV manufacturers incorporate those into their designs, and you can always add it aftermarket. So that is a solution. And oftentimes the customers, your customers, if you have a campground that have the most demand for good Wi-Fi, are going to have those repeaters. But there are always going to be users that don't have those. So that can cause a problem as well. And it's not just RVs, it could be other vehicles, or if you're trying to cover an area that has, maybe tractor trailer trucks that are in an outdoor, like a loading bay, or it could be school buses in a lot of a school or something like that. So we have to deal with these vehicles that are metal, and it's very hard to get signal into them. And then mentioned it at the top, but the problem of getting the backhaul or the signal to the access points. So that can be very expensive in outdoor areas. When you're talking about indoors, oftentimes everything can be covered with a copper Ethernet connection, and many times we have easy access. It can be difficult at times, but oftentimes we have drop ceilings, and it's pretty easy to run that cabling. There's not a lot of labor costs involved. When we're talking about outdoors, especially over large areas, you can get into significant costs in trenching in fiber, and that can start to really add up. And then in cities, you also, that can even be more expensive, because now, potentially I'm having to go through concrete, and I may have issues obtaining right of way to even have permission to lay that cable. So both from the right of way aspect, as well as just the labor costs involved in running some of those cables, that's definitely a challenge as well. So moving on to some topics on how you can deal with these challenges, and what do you do if you want to design for outdoor coverage. So there are some tools that can help you. The first one that probably comes to mind is these predictive survey tools like Ekahau. So these type of tools, they are very good at modeling open air coverage, or what we call free space path loss. So the tool will have all of the AP antenna patterns built in, and it will know how to do the math to determine what the coverage is going to be. But it's very difficult to model things like buildings and foliage. And typically these tools do not model terrain. So the actual elevation data of where you may have a hilly environment that you have to deal with. So there are tools out there that you can import terrain data into, but even getting a hold of that very fine resolution, accurate terrain data can be kind of expensive and require some very specialized tools. So in many cases, we don't have access to those. But what you can do in a tool like Ekahau with, for example, for buildings, you can use things like attenuation areas and custom wall attenuations to build up, start to build up a model of what the environment looks like. But if you get into something like a city where you have many of these buildings, that can really take a long time. So you have to factor in, if you want to do a predictive survey, it can be difficult to get enough data to accurately model what the outdoor coverage is going to look like. And also you have to, you may not have all of the data, such as the terrain data. So, but definitely this type of tool is very useful. Another tool that can be very useful is Google Earth. So Google Earth has a Google Earth Pro version, which you can download. And in the Google Earth Pro version, which is free, there are some additional tools that let you do things like measure distance and get an elevation profile. So if, for example, you need to have a wireless bridge link between two buildings and you're unsure on, whether you have, well, you can tell if you have line of sight by getting to the 2 points and visually sighting across. But if you're not on site and you have to make some estimates to get the initial design kicked off, then a tool like Google Earth Pro can be very useful because it allows you to see, not only map an individual path and see what that elevation profile looks like, but sometimes just having access to that satellite imagery can help you understand the environment and what sort of obstacles there are. Where are there trees? How thick is that foliage? are there open spaces in it, and so on. So that's another tool that can be very helpful. And then finally, really the most helpful tool when you're designing for outdoor coverage is AP on a stick survey. So there's nothing like actually taking real measurements in the real world. We always prefer that where possible for indoor coverage, but the indoor coverage is a lot easier to model in a predictive survey. So in many cases indoors, we'll do a predictive survey, and we always recommend a validation survey with actual measurements after the fact, because you may need to make some adjustments. But for the most part, predictive surveys work pretty well in indoor environments. When it gets to outdoors, it's very mixed. Certain environments, you may not have a lot of trees to deal with. There may not be a lot of buildings. Sometimes you can fairly accurately model things, get pretty good results with a predictive survey. But really, I always recommend if you can get on site and do an AP on the stick survey, it is the best way to understand the real world coverage. And you can still, of course, do this with a software such as Ekahau, where you can take your AP and do multiple surveys with a single AP and then combine those surveys together to get an accurate view of what the coverage looks like. While you're doing that AP on a stick survey, or you're potentially even at a first site visit, another thing to keep in mind is, what does the RF spectrum look like? So it does tend to be noisy outside. The RF noise that comes from either other Wi-Fi signals, or it could be non-Wi-Fi signals, with nothing but just the air to attenuate, that noise can travel long distances. And therefore, doing spectrum analysis and understanding what the noise floor is in the environment is really important to understand what you're dealing with. So always recommend that. Directional antennas can also help here as well. Whereas if you have something like an omni antenna, then of course, you're going to get wireless coverage in 360 degrees, but that AP is also going to hear any noise for that full 360 degrees. So directional antennas can help with that. And where you do deploy directional antennas, oftentimes we'll want to put some down tilt on that antenna. And so what I mean by that, if you're not familiar, is instead of just, say you have a sector type coverage pattern for your AP, instead of just pointing it out horizontally, what we want to do in most cases is tilt that AP down a little bit. That will bring in, it will reduce the range, potentially a slight amount, but also what that does is, by pointing the AP a little bit away from the horizon, it also reduces the amount of noise that you're going to get. And that can help you also with not interfering from one AP to another. So being able to use a directional antenna and put a little bit of down tilt can help you more clearly define what those coverage cells look like. Mentioned campers and RVs earlier. When you're dealing with that kind of environment, tractor trailers, whatever it might be, it is important to get the AP high enough above the RVs to where you can get that coverage down in between, especially when you have something like an RV park where you have a lot of these tall metal vehicles parked pretty close to each other. If you can get the AP high enough, then you can kind of beam it down into those adjacent spots between the vehicles. So that can help as well. So those are some tips, just a very generic kind of outdoor, here's some things that you can think about as you're trying to design for outdoor coverage. But Ruckus also brings some things to the table that can really help as well. So I want to talk about some of those things. And to start, I want to just level set on what is required to have an outdoor access point, really any access point, to serve clients. So the requirements really are power and backhaul. So you have to power the thing somehow, and you have to get the connectivity to it, because you don't just want to connect to that AP, you probably want to get to the internet. Indoors, we typically use copper Ethernet to cover both of those, both power and backhaul, and that works out quite well. Outdoors is a little bit different story. So there are many cases where you can still use your copper Ethernet for both power and backhaul outdoors, but it can be challenging to get the Ethernet to each AP. And you do have that distance limitation, generally 100 meters on a cable run, on a copper cable run, without some kind of switch or repeater to boost that signal. And fiber can be used to extend those distances. You can go, many kilometers, up to 80 kilometers or more with fiber, depending on the type of optics, and you can always deploy amplification there as well. So the 100-meter limitation goes away, but if we're going to use fiber, we already mentioned there can be some significant labor costs in actually trenching that fiber in, and in some cases you may need permission to dig. So definitely more difficult outdoors in many cases to get that connectivity to the AP. And when using fiber, now you don't have those copper conductors which carry the power as well. So very conveniently, with a PoE switch and copper Ethernet, I can have both my connectivity and my power run over the same line to the AP. We don't really have that necessarily with fiber, but we have a solution for that. I'll talk about it here next slide. And then mesh is also something that you can use in place of fiber. So mesh being the idea of one AP communicating to the other using a wireless signal. And that can, in many cases, reduce the need for fiber or copper cable runs, but we do still need to somehow get power to those APs. So one way we can solve this power problem if we want to use fiber is with the power fiber cable system that CommScope offers. And basically, this is a power supply. It's a system consisting of a power supply and some distribution. And then we have the PoE extenders that you can place at the end of these runs. This allows you to push basically a fiber and power out up to 3 kilometers if you only need 15 watts of power, or 1.6 kilometers for 30 watts of power, and then 650 meters for 60 watts of power. So depending on the power needs, in many cases, 15 watts is enough. So you see 3 kilometers is quite a long distance. In most cases, 1.6 kilometers is more than enough. So we can push that, both the signal and the power out. And the way that works, really, it's pretty simple, easy to understand. It's just a hybrid cable that has fibers, could be up to 12 optical fibers, as well as some copper conductors, all in one cable. And it's designed to be very easy to use, easy to kind of peel those conductors apart, and easy to strip both the fiber and the copper conductors. So with the powered fiber cable system equipment, at your source, that will inject the power as well as the signal into this hybrid cable. And at the other end of this hybrid cable, we have basically a converter that's outdoor rated, so rated for extreme temperatures as well as inclement weather, rain, and so on. And that will terminate in a standard copper RJ45 PoE connection. So basically, it's like extending your PoE port out, up to a couple kilometers. So this is one way if you have to get a further distance in which you can run with copper Ethernet, and you want to be able to provide both power and that fiber connection, this hybrid cable is a good solution for that. In addition to having that power fiber cable system, we've also done some creative things on some of our APs to make deploying easier and to solve some of these challenges. So for example, here we're looking at our T710 outdoor access point, which is our high-end Wave 2 Wi-Fi access point. We also now have the T750, which I'll show you a picture of here in a minute, which is similar, but I wanted to use this slide because it's a nice description of the functionality for the T710. T750 looks just like this. So basically, this access point, you can power it with a copper PoE cable, or you can run fiber. If you run fiber, we can actually accept an SFP connection directly in the AP. So you put your optic directly in the AP and then connect your fiber directly to that. And then we have additionally an AC power input. So in this example, you could, if you already have power at the site where the AP will be placed, then for example, maybe it's a light pole. You can mount the AP to that light pole and I can power that AP directly off the AC power that's present in the pole. And I just need to run my fiber to the AP. So I can splice in, if I have my fiber run going by, I can splice in and pull that off to the AP. I can power the AP directly off the light pole and I'm up and running. So that's one option that we have, both on the T710 and the T750, to let you use that direct AC power, which can really help solve some of these challenges. And then the T750, of course, this is our 802.11ax or Wi-Fi 6 outdoor access point. So this is going to be the current model. Everything I showed you on the previous slide is present on this AP as well. So you can see there, it's got the SFP connector, the PoE in, and the AC. And actually, I forgot to mention the PoE out, which is important. So not only does this AP have the ability to be powered either via a PoE input or AC power directly, but in either, if I power it with the AC power, I can actually provide PoE out as well. What that means is I can connect something like a surveillance camera to this AP and with just a standard PoE connection. So if you're going to deploy the AP and you need to put a camera there or any other device that can be powered via PoE Ethernet port, we provide that capability. And what this also means is if I need to add outdoor coverage, say to one of my buildings, and I already have a PoE IP camera there, then I can put this in line and power my camera as well. You know, depending on the amount of power that I push to the AP, determines how much budget the AP can then daisy chain off to the device that's connected. So that's a really creative solution. So the T750, of course, is a 4x4, 4 spectral stream Wi-Fi 6 AP. And it does have the 2.5 gig Ethernet input as well as the SFP connection. And you can power it either via PoE or the AC power. I want to mention some benefits of putting in a Wi-Fi 6 solution versus a Wi-Fi 5 or 802.11 AC solution. So we do carry, you know, both 802.11 AC Wave 2 APs that are suited for outdoor use, as well as the newer Wi-Fi 6 802.11ax APs. Moving to Wi-Fi 6, one thing that's changed is we now have the ability for outdoor APs to use a much longer guard band interval, which allows more time for reflections to settle and gives you better multipath performance. So I mentioned earlier, talking about reflections that can be a problem in urban environments. Where you have lots of those reflections and where you're going over longer distances, you're more prone to those reflections causing problems. And this longer guard band interval is a way to solve that problem, as well as the other, all the other things that have been brought into Wi-Fi 6. You know, probably the biggest one is this OFDMA, which came from the LTE world, which allows shared access on a single channel. So instead of having only one device talk at a time on any given channel, we can actually have multiple devices share that channel simultaneously, which is important where you may have needs for connectivity more so than bandwidth. And if I can get, you know, if all those devices are just doing some basic web browsing, I don't necessarily need to hog the, you know, all of the bandwidth the AP has. I can split that up across multiple devices and get them all on and off quickly. And the long guard band interval, just to explain that a little bit more. So in prior to Wi-Fi 6, the longest guard band interval that you could set was a 0.8 microseconds. And now we can use 3.2 microseconds. So it's a pretty large change. And basically what this means is that in between every bit of information that's sent, there's this guard band. And the purpose of the guard band is to allow any of the multipath reflections to settle, to allow the AP or client to more easily interpret the signal from all the reflections. And as you get to longer distances outdoors, those reflections can really pile up. And that's why this longer guard band will really give you a better experience outdoors. So I do recommend looking at Wi-Fi 6 for your outdoor deployments. And of course, being that we're Ruckus, not only do you get all the good stuff that comes with having Wi-Fi 6, but we build our special sauce on top of that. So here's a picture of one of our BeamFlex antenna arrays. BeamFlex being the Ruckus patented technology that allows us to dynamically adjust the signal to point towards the client. So where you have something like a T750 omnidirectional AP and you're looking for 360 degrees of coverage, with BeamFlex being built in, we actually will, on a wireless frame by wireless frame basis, as each individual client is transmitting each individual frame, we can actually adjust the directionality of that signal as well as the power of that signal. So it gives you a stronger signal to the client, which means they can go faster. And then of course, if they go faster, they get off the AP quicker and freight up for the next client. But also it reduces the susceptibility to interference, because if I can be more directional, then I'm creating less self-interference. And that's always a good thing. Then the other Wi-Fi 6 AP that we've just announced recently is the T350. So this is our more mid-range outdoor AP available. It's a 2x2, 2-stream, and dual band. And it's a very good choice, and especially if you have some particular power problems that you're trying to solve. So this one doesn't have the AC input that the T750 does, but what it does have is a 12-volt DC input. So here's a picture of this. So this AP can be powered either by PoE, copper connection, or we can power it with a 12-volt DC connection, which actually ranges up to 20 volts. So one of the really nice benefits of being able to accept a 12-volt DC connection is now it makes it really easy to do something like power the AP by solar or wind power, more probably solar. If you haven't been following the market, the price of solar has really been coming down, and it is, in addition, the battery technology has been vastly improved over the past decade or so. And so the situation we're in now is a combination of high efficiency solar cells with the newer lithium battery technology means that you can, fairly cost effectively deploy access points that don't need any infrastructure. So if I can power the AP with a combination of solar and battery, and I can use something like wireless mesh, which we'll talk about here shortly, to get the signal to the AP, then really the possibilities are limitless at that point. So this makes it very easy to extend coverage into areas that just don't have a lot of infrastructure. And then one last AP I wanted to talk about, and of course we have Wi-Fi 5 versions of all these APs as well. And this one is a Wi-Fi 5. This one has not been refreshed to Wi-Fi 6 yet. I want to point that out. But this is our E510, which is our modular embedded access point. And the unique thing about this AP is you can see there's two parts to it. Both of those parts are fully outdoor rated and can, submersible and subject to extreme temperatures. But the piece on top is the basically the intelligence of the AP, and the part on the bottom is an antenna module. The antenna module does still support our BeamFlex technology. So you'll see there's a couple of connectors on there. We have 2 RF connectors as well as control connections to carry those BeamFlex decision signals from the AP to the antenna module. And where I would recommend this AP, it's really more for environments where aesthetics are very important. So if you need to cover something like city streets in a very kind of high-end area where you've got really nice street lights, everything is like very well maintained, and maybe there's the city council has very large concerns about how this new wireless is going to look, then this is a good one to deploy, because the AP module can be fit in many cases inside a light pole, or even inside something like a bus stop enclosure, or any kind of like signage that may be on the street. And then all you have to have exposed is that little antenna module at the bottom. So just kind of keep this in the back of your mind for if you come across that type of issue where aesthetics are really important, the Ruckus E510 is a good choice for those environments. And then when you're thinking about which AP you want to deploy, one thing to keep in mind is the antenna pattern. So we do offer APs in different types of antenna patterns. Of course, we have the omnidirectional, which is easy to understand. It's 360 degrees of coverage. And then we have 120-degree sector, which is probably the more common. And you can see what that looks like. So if you have a 120-degree sector, it is going to allow you to focus the coverage in that 120-degree area, which of course gives you a stronger signal within that area. And then it reduces susceptibility to interference outside of that area. And then if you need to provide 360 degrees of coverage with really high capacity, then you could actually put 3 of those on one pole, as you can kind of see there in the diagram. So if I put 3 of those on the pole, I've now covered the full 360 degrees. Oftentimes outdoors, it's really more about coverage, and we would often use an omnidirectional AP for that. But if you need to, if you have challenging areas to cover, like I mentioned, being able to use the directional antennas to put a little bit of down tilt on it allows you to much better control the wireless cell coverage. And also, if you need to have high density outdoor coverage, for outdoor events or something like that, that's where you might want to think about putting 3 of these sector APs on a pole to increase. Basically, you now have 3 times the client capacity. And then where you need to have a really finely tuned, smaller pattern of coverage, you might use something like a 30-degree sector antenna. And this can be useful not only for coverage of wireless clients, but if you need to do something like just using either wireless mesh or a wireless bridge to have a point-to-point connection between 2 buildings, that's where you might prefer to have a much more narrow antenna pattern to really push that signal exactly where you're trying to get it. Speaking of wireless bridges, now we kind of covered the power issues that we see in outdoor wireless. I want to talk a little bit about the other problem, which is how do you get the connection to the AP? So we have 2 ways. There's a few ways of doing this. Talked about fiber, talked about copper cabling. We also have means of getting connectivity to the AP with a wireless signal. So really the primary 2 ways you see this is with either a wireless bridge or mesh connectivity. So there are point-to-point bridges in the market. We have the Ruckus P300, which is a pretty simple to deploy. There's no configuration. You can buy them as a pair. They're mated. You take them out of the box. There's an aiming button on it. You press the button. You point them at each other. You watch the lights, light up, and it's got like a signal strength graph. And that's basically all there is to it. And they'll pass all VLANs that you want to tag to it from the switch. So it's really easy to deploy. We also oftentimes partner with a company called Ciclu, who makes a wide range of nice point-to-point, multi-point bridges. So that's one way of covering it. The other way is to use mesh, which we'll talk about in a second. Now, whether you're using a wireless bridge or mesh, or actually this applies to any wireless signal, but it mostly comes up with these point-to-point links. We have to be aware of something called the Fresnel zone. I apologize, this picture's a bit blurry. Fresnel is actually spelled like Fresnel, but it's pronounced Fresnel. It's a French word. And what the Fresnel zone is, it's this football-shaped pattern that you can see between the 2 antennas. And you can look up how to do the math on this, and it's a little bit different for each frequency band. But basically, when you're talking about line of sight, it's not that you can draw a line directly from one antenna to the other. Line of sight actually means that the Fresnel zone, or more technically the first Fresnel zone, because there are more than one, is free of any obstructions. So if that, and you can run the math on what that radius is, what that Fresnel zone, if there are no obstructions within that Fresnel zone, then you have what we call line of sight. If that Fresnel zone is partially obstructed, then we have what we call near line of sight in the middle. And then if it's fully obstructed, then that's non-line of sight. Non-line of sight is really challenging to cover. We do a good job with near line of sight, and of course, line of sight is what you're hoping for there. So if you have something, and this is where you can use, like I showed earlier, the Google Earth Pro or some kind of elevation profiling tool that you can put 2 points in and you can kind of see what the terrain is in between. What you're looking for there is to make sure that Fresnel zone is not obstructed. So if it is obstructed, like you see in like the bottom picture there, the way you get around that is to raise the antennas up. So you can put the antennas a little bit higher on masts and get free of that. And the other thing that I want to point out here, when we're talking about Fresnel zone, if you look at that picture at the bottom, so we've got a tree in the middle, and this applies to both planning point-to-point links as well as just general wireless coverage. And it may be a bit obvious to say this, but if you're doing your survey in the wintertime, where there aren't leaves on the trees, even if you're doing an active survey, without those leaves on the trees, you're not going to have that signal attenuated. And you may be in for an unpleasant surprise when spring comes around and all those leaves start growing and that signal now gets attenuated. So that's something to kind of keep in mind, that as you're doing these outdoor plans, you want to kind of keep the worst case scenario in mind. So talk about bridges. I want to talk about Ruckus Smart Mesh. Ruckus Smart Mesh is a really cool technology that we have built into all of our APs with a couple minor exceptions, like the very low end, like an R320 or an H320, like the very low end stuff. Not that it's low end, it's still Ruckus, right? But those APs don't support mesh. On the whole, everything else does. And this is provides a few different benefits. So the main thing with mesh is, stated in the most simple way, it's how do you get connectivity to the AP if you can't run a cable to it? So we can use the wireless radio to communicate between APs. So in this diagram, what you see is at the top, you have the controller and a router that connects to the internet. And then you have that first row of APs is what we call the root AP. So a root AP, it just means that AP has a cabled connection. In our Ruckus Smart Mesh, we have the ability to make an intelligent decision on whether to use an Ethernet connection or the mesh connection. And you can configure that in such a way that if you would like to, you can hard code that and lock the AP to a particular role, or you can leave it set to automatic. And if you leave it set to automatic, the way that the system will work is that the root AP will prefer the wired connection. And if that wired connection becomes unavailable, then the AP will attempt to mesh. So this is not only a solution for providing coverage where you can't get a cable, but it also gives you a little bit of redundancy if that cabled connection goes down. And then you have your mesh APs, which are the APs below that, where you can see the blue dotted line that indicates a wireless connection. So so this is what we call a standard mesh deployment. Then we also have something called eMesh or hybrid mesh. So really all this means is if you look at the the A and C there, or your well, actually the A there is your root AP. The B and G are your mesh AP, so they're just wirelessly connected to A, which is the root. And then AP with the C label is another mesh AP connected to the root called A. And then we have some APs that are connected to APC with a with a cable connection. So I can actually mesh an AP and then use the Ethernet port on that AP to connect other APs to it. So, and this is what we call eMesh. So when you're doing mesh, there's a few things to keep in mind. So first of all, I have to point out that there is a hop count limit. So we have a hop count limit of 7 hops. That means you can start at the root AP and then you can hop through 6 more APs, and then beyond that we don't support that connection. Now you really aren't going to most likely want to get to 7 hops anyways. We'll talk about why here in a minute, but we do support 7 hops. So one of the downsides of mesh is that in order for the AP to be able to connect, it has to be on the same channel. So for example, if I have APs B and C meshed to APA, then all 3 of those APs need to be on the same channel. And as we know, having APs be on the same channel is not always a good thing, because that can create contention. So in many cases, you'll have these APs that are meshed will be in physically disparate areas from each other, and that can not be as big of a deal. And then also where we're talking about outdoor mesh, we oftentimes don't have quite the bandwidth requirements that we have indoors, so it tends to not be as much of a problem. But when we do something like eMesh, now those APs labeled E and F are connected to C via cable, and they can actually also act as mesh APs for other APs to mesh to, like you see H and I. H and I are connected to E and F. E and F do not need to be on the same channel as A and C. So because that copper connection is there. And so we sometimes use this to get coverage down streets. For example, I may put APs on light poles, and the one AP may mesh to the next. And then I may have, like say I'm using something like 120-degree sector, I'll put them back to back on the light pole, and I can just cable between them. And so every other hop is a wired hop, which means I can change channel every other hop. So being able to provide this flexibility is really an advantage with the Ruckus Smart Mesh solution. And then there's the topic of when do we use mesh versus when do we use a bridge. So basically, in many cases, the bridges are going to give you a longer range of connectivity. And then also some bridges are only available in a point-to-point configuration where I can only have 2 radios on either end, and it's basically like a virtual wire. Or some of them are available in a point-to-multipoint type of configuration where I can have one root bridge and multiple other bridges connected to that. So if I only need a point-to-point connection and I only have two locations and it's longer than about 300 or 400 meters, that might be a good use case for a bridge. And a bridge also is typically going to have lower latency than a mesh connection. On the mesh is when you need to connect multiple locations, like a point-to-multipoint type of situation, and typically for shorter distances. And you can use any of our APs for this. So typically, we're talking about outdoor here. So any of the T-Series APs support mesh. We can use those for that. And if we're just trying to get across the street, or even out to a couple hundred meters, no problem to use those. And then you get the benefit too that those can also be managed in your smart zone or Ruckus Cloud Management, which is nice. And then finally, wireless mesh design considerations. Basically, we talked about survey. Everything really should start with a survey. You need to understand the RF environment. You need to understand, how you want to select your channels that you'll use, what kind of interference there may be, what kind of mounting sites there are for APs, and the expected distances. We talked about how we need to keep the Fresnel zone clear. And really, the rule of thumb is, if you can cable it, mesh where you have to. So try not to rely too much on mesh, but where mesh is the solution, don't be afraid to use mesh because we have a solid solution there. Some of the things to keep in mind when you're talking about mesh. So because when we mesh, we typically will mesh on the 5 gigahertz radio, although we do have the capability of meshing on the 2.4 gigahertz radio. The trade-off there is the 500 gigahertz radio is going to give you more throughput, and there are more channels available. You can use wider channels on 5 gigahertz to get more throughput, but the signal does not penetrate as well. So if you're trying to mesh outdoors and maybe you have some trees and you need that little extra bit of distance, and maybe bandwidth isn't a huge concern, you might want to consider using 2.4 for your mesh connections, but typically you'll use 5 gigahertz. And whichever one you choose, let's say we're using 5 gigahertz, which is the default, then that 5 gigahertz band will be used both for client connectivity on that AP, as well as the uplink to the next AP in the mesh. And so because that is shared, what we typically will see is that and also we have to repeat the signal between APs. So we'll typically see that the throughput that's available between 2 APs pretty closely matches the formula of 1 divided by the number of hops. So for the first hop, you get whatever that throughput is. Like here we have 300 megabits. I mean, that depends on lots of things, channel bandwidth and the available, the signal strength, signal noise ratio, et cetera. But let's say it's 300 megabits per second is what we get. Then the next link is going to be 1 divided by 2 hops, or 1 divided by 2 is 150 megabits per second. And then the third link, you have 1 divided by 3 or 50 megabits per second. So you can see how as you get further from the root AP, the throughput is going to drop. And then also what we're going to have the latency is going to be incremented as you move across these mesh links. So typically each mesh link is going to contribute about 15 milliseconds of latency. So in this example, with 2 mesh links, the 2 mesh links and then all the way to the client is about 45 milliseconds. And then if you're talking round trip latency, then 90 milliseconds. And typically if you need to support voice, we typically say you want to be under 150 milliseconds. So that's just something to keep in mind. So if you start getting out to, like double this number of hops, you can see where we'd be over that 150 milliseconds. So that's something to keep in mind if you have to support latency sensitive protocols like voice. One last thing I want to mention on the AP solution is that all of our Ruckus Wi-Fi 6 APs have IoT radios built in, and you can add IoT radios to the Wi-Fi 5 APs with a USB stick that we have as well, and that actually ships with an extra long cover to maintain the waterproof seal on the AP if you use the USB stick. And typically we see this more in cities, but there's lots of these IoT sensors. So if you need to support any of these, if they're Wi-Fi, you can connect it directly to the AP. But if it's something like Zigbee or BLE, we even now support LoRaWAN by integrating a LoRaWAN network server. So any of those protocols, you need some of these sensors deployed outdoors. Ruckus is a really good solution for that because we integrate with the Ruckus IoT controller. I also wanted to touch on mobile Wi-Fi. So mobile Wi-Fi is the idea of putting APs in vehicles. And what we have for that is the RECUS M510. This is an 802.11ac Wave 2 AP. You can see on the right there, it looks a lot like an R510, and it basically is an R510, which is a 2x2 Wave 2 AP, except we built in LTE backhaul. So what you can see on the right, the two vertical black antennas, those are the LTE antennas, and that little black puck is the GPS antenna. So what this allows you to do is to use an LTE signal to provide backhaul so that you don't have to run fiber or copper. As long as you have that LTE signal, you can then convert that to Wi-Fi and get the users on the internet. And one example of where we see this is in school bus Wi-Fi. So we have some customers that have put wireless into their school buses. And in this example, what you have is an M510 in the bus to provide the LTE backhaul. And then we have two sector outdoor APs on the sides of the bus and a compact switch. And all of that cable together ends up looking something like this in the end. And you can see, in this case, I actually have two sectors on each side of the bus. And with the LTE radio inside, I can provide coverage both inside the bus as well as outside the bus. And what we see some customers doing is they'll take these buses and you can park them in various areas where maybe you have kids that don't have broadband internet. And this can be a nice way to get them access and even tie these back into the same management as what the school was using so that I can use my school credentials to get on that outdoor Wi-Fi. And that, we see this being used as mobile hotspots. And then we also see some of these being used for, in response to kind of the COVID situation that's been ongoing, for healthcare and, providing places for kids to pick up homework and maybe supply some food for students that need some assistance with their lunches. So we've been seeing some good success there. And we've also seen, while we're on the topic of education, we've also seen public libraries coordinating with schools to tie into that same ruckus management system that the school is using and be able to give the kids the ability to go park in the library and use their school credentials to get on, or to go park at the school and use their credentials to get on. So that's a really nice solution. And then I think this is my last slide. One final thing is we also have this thing called the CommScope Rapid Deployment Unit, which you see here. And this is a completely self-contained outdoor Wi-Fi unit with a powered extendable mast that also has the ability to provide LTE backhaul, or you can provide a wireless bridge backhaul and point that to, say, another bridge on top of a nearby building. So if you have the need to provide like rapid response Wi-Fi, this is something to keep in mind. We also have this in a self-powered version where it's got some onboard battery as well as an onboard gas-powered generator. So you can just deploy this, get the generator going, and then you're good to go with good coverage for whatever that outdoor area is.
That is so cool, John. Thank you so much. I do have a few questions to run by you. Are you ready for questions?
Sure, let's do it.
Okay, so the first one is we have a school and they're doing a tower and they have a 750 pointing in 3 directions. And what he wants to know is, does he need to run a cable to each, or could he just run one cable to one and then daisy chain them?
No, we can daisy chain APs. So I have done that before. It is possible. And basically that port is that port on the AP is configurable, and then you do still have to get power to it. So we have to look at the what the power requirements are and look at the specifics on the power budget and all that. But in general, yes, you can daisy chain one AP off another.
Okay, the next question is, what is the distance on mesh between APs?
So this is where I get to use everyone in Wi-Fi's favorite answer, which is it depends. And it really does, but you can get a couple hundred meters. It's going to depend on the environment and the type of antenna that you have on the AP. But certainly you can get a couple hundred meters.
All right, and then this question, I think I know the answer to, but I don't ever like it. But is there a plan to move away from just AT&T? I'm sure that we're talking about the mobile.
We're talking about the M510.
Yeah.
So nothing committed currently to the roadmap, but it is something that we've had some discussions on, and but nothing to report today on that topic, unfortunately.
Okay, the next question is, the standard PoE port, could it also be connected to a switch?
Absolutely, yeah. I mean, that's a very common use case. So if you're just putting APs on the outside of a building and you can get copper Ethernet there, that would be my first choice.
Awesome. And then I'll answer this last one here, and the video will be made available for later viewing and reference. We will send a copy of this video out to everyone that registered for this webinar, and then I'll also host this webinar on our outdoor AP landing page, and I'll throw that in the chat window for you guys. So as soon as this is put up onto YouTube, then I'll add the video up onto this landing page right here too. Okay, another question I have for you, John, is when will 6E products be coming out? He'd like to do both at the same time.
So I would say stay tuned on that and coordinate with your Ruckus sales team. We're expecting to get a refreshed roadmap out shortly, and but basically that's a little bit further out on the outdoor, because we're starting with the indoor 6E. So I would say wait for the roadmap refresh, and we'll be able to have those communications with your salespeople.
And then there's a couple questions I can answer here too. That website that I just put into the chat, there you can go in and request a quote right from there. Select the outdoor APs if you want, and if you want to talk to an engineer, we can get something scheduled so you can talk specifics on your space that you're trying to design around, and we'll do our best to help you get what you need. And then there are some delays that you guys are going to see with different outdoor APs. It looks like I just had a ton of stuff pulled up. It looks like AC stuff is more available than the newer stuff. So my advice is to put in orders now for projects that you're looking to do. We can delay invoicing till July to help people kind of get their orders in and get in line. I did pull some lists from distribution before we started this webinar, and there is actually better availability on some different models than I was expecting. So depending on what you're looking to do, there are some different models available, but there are definitely some that are back ordered. And I know that they're working hard at Ruckus on getting some of that stock up and out there. There's been a pretty big demand issue going.
Yeah, we're definitely seeing this issue. I mean, that's industry-wide, not even industry-wide, right? We're seeing it even like car manufacturers are having to stop assembly lines. So that's affecting a lot of folks. We totally understand that. We're doing lots of work behind the scenes to reduce those timelines. So we totally, that's like one of our top priorities.
Someone had just asked about grants, and I'll share with you guys, Ruckus has a really awesome program right now where if you're looking to do a big project, they will help you pull a grant funding report that'll just pull all the different areas where you would be able to qualify for funding based on the projects that you're looking to do. I personally just sat through one of the grant funding meetings last week, and I was super impressed. It's very comprehensive, as much as 30 or 40 pages, depending on what you're looking to do, and all sorts of different funding sources that are available for the different projects and where you're sitting on everything from CARES to private grant funds. So it's a really, really great resource. If you're interested in doing that, I'll just put my email in the chat, and just let me know, and I'll fill out the form and get that requested for you. Any other questions or anything? Thank you everyone very, very much for joining us. Thank you, John, for going through that with us, and I really appreciate it, and I hope everyone has a great day. If you guys need anything at all, please shoot us over an email.
Yeah, thanks for the opportunity to talk about Ruckus. I always love doing that, and thank you everyone for your time attending. I hope it was useful.
Thank you.